Hey, Shafras.
Hey, Jiazin, how are you?
I'm good. How are you?
I'm great too, and super excited to be in this most anticipated event.
Yeah, every single feedback we get people asking for this topic.
Yeah,
So today we are finally doing it.
yeah, let's do it.
Yeah. Hi everyone. Welcome to our channel. And I'm Jiaxing and this is Shafras. We are both from the Google Developers Relations team. We hope everyone is keeping safe and well wherever you are. Do leave a comment on the live chat and let us know where you're tuning in from. Before we begin, I think our fourth in the cloud event, let us share a little about who we are and what this is all about. Google Developer Space is a home for developers and startups from the region to learn, connect, engage, and be inspired. We want to empower and connect the community to our people, programs, network, and technologies. Without further ado, I would like to pass the stage over to Shafras, our main host for tonight. Yeah, Shafras, do share with us more about today's highly requested topic and the awesome speakers we have joining us.
All right, thank you very much, Jiazin. Thank you very much to Jiazin, and then the developer space team at Google Singapore for hosting the event and supporting us with all the infrastructure that they have. So thank you everyone. Thank you everyone for tuning in today. So this is one of the most anticipated topics which we received for since the start of the program in the cloud. A lot of people were asking, "Hey, can we do an event on Kubernetes and Google Kubernetes engine as well?" So today is that day. So
Finally,
in yeah, that's really cool and very awesome as well. So in the cloud talk show is all about discussing and the latest and the greatest of Google Cloud technologies with the experts in the field. So the topic today is going to be on Kubernetes and Google Kubernetes engine. The viewers who are joining with us, you might have questions from early on even before we start off the program. Please do leave that in the live Q&A section so that we can help you out to answer those questions. And also, I should remind you that if you want to talk about Kubernetes, if you want to talk about Google Kubernetes Engine, we can talk about the whole day. But since we don't have time to do that, um, uh, we'll not be able to discuss on the edge cases or
mm,
specific scenarios you might have. So the best thing that you can do is if you want those to be answered or picked up, to just leave it in the Q&A live Q&A section. So I think we can give a small, like we showcase to you the speakers who are joining us today. So we have Giri Kuncoro, who's a Google developer expert on cloud, and then he's also a software engineer at Gojek. And we have Suat Hoon, who's joining with us today. She's a technical solutions engineer at JP Morgan Chase, and she's also a Women Developer Academy graduate, which was conducted by Google Developer Space. So, without taking much time, let's invite Giri and Suat to this
hello.
show. Hey, Suat.
Hey,
Hey,
Shafraz.
Giri.
Hello.
Hey. Great to have both of you in today's show, and thank you for joining with us despite your busy schedules. So, why don't we start off by giving a small introduction about yourself? Who wants to go first?
Yeah, sure. I can go first.
Okay.
Hey, folks. Thanks for having me here. Very pleasure for me to be here. My name is Giri. I live currently in Jakarta, Indonesia. I work as a software engineer in Gojek, one of the unicorns in Southeast Asia. I'm also a Google developer expert for cloud, as well as a Cloud Native Computing Foundation ambassador, which hosted a foundation that hosts a Kubernetes project as well as other popular cloud native open source projects. Yeah,
All
that's all.
right. Awesome. Thanks, Giri. Great to have you on the show. Suat?
Yeah. Hi everyone. So thanks to Shafras and Justin because actually I joined the Women Developer Academy last month, and then I got my chances to know Shafras and Justin and have the invitation to join everyone here. So I'm a technical solution engineer from sitting in JP Morgan Chase, Singapore. So my part of my job duty is to support the private cloud platform that we have in JP Morgan's, and one of the platform we have is a Kubernetes. So basically, I'm also a designated SME to support Kubernetes in APAC region. Yep. So yeah.
All right. Thank you very much, Suat, and it's great to have you on the show as well. So to all our live viewers, I would like to request you, if you have any questions, please do drop it in the live Q&A section. And also, please do tune in with us till the end, because at the end, we'll be announcing some of the free training sessions available for you to try out, so you can get hands-on experience with Google Cloud. And also, there are some gift giveaways once you complete feedback form. So please do tune in, so you can be the lucky winner as well. So this program today, the session today will have two sections. The first section is the rapid fire chat. We'll ask some of the high level topics. We'll ask questions from high level topics around Kubernetes and Google Kubernetes Engine. And then after we have finished off the rapid fire chat, we'll be moving on to the deep dive session, where we'll have more in-depth discussion around these technological pieces. So I would love to request all of you to tune in and do share with your friends who are not watching at this moment, so they also can be can be benefited out of this program. All right, without taking much time, so we can move on to the rapid fireside chat. Awesome. So, all right. So, in this rapid fireside chat, we'll be asking questions from both the speakers. So, to start off with, the first question will go to Giri. So, Giri, everyone would love to know, what is Kubernetes and why Kubernetes is important?
Okay, I know this will be the first question, and what comes in everyone's mind, because Kubernetes is just so popular right now. But most of people just know the buzzword without knowing what it is really. So in one term, I would say Kubernetes is an operating system for the cloud infrastructure in this modern era, right? And historically, it's actually originated from Google internal projects. It's been used in Google internal project called Borg to manage their own containerized workloads that they have been running for, if I'm not mistaken, around 10 or 15 years to serve billions of users, right? That Google have. So they donated this project to open source community so that everyone else can benefit from it. Yeah, I would say why is Kubernetes important? It's because in this modern cloud native infrastructure, in the past, people only managed one monolithic application. Now they have broken down the monolithic app into several microservices, even hundreds. If it's not tens of microservices, hundreds of services, it can even go to 1,000 services. Without something that can manage this easily, it's really hard, to manage it in a resilient manner, scalable way, as well as reliable.
Yeah, awesome. I think like having Kubernetes as one of the open source projects and supported by Google, there are a lot more developers who are contributing, and also Giri himself is also contributing to the docs and also some of the projects which are happening already inside Kubernetes. So you might be also someone who's also supporting all these activities. So leave us a comment if you're also part of this movement. All right. So we now are moving to ask the second question from Suat. So Suat, so tell me now, when it comes to Kubernetes, there's this there are certain things which people have to know before using Kubernetes, right? So so tell me, Docker versus Kubernetes, what's the difference, and which tech do you think first developers should know? And
Okay. So
why do you think it should be the technology as well? Yeah.
So actually, I think this is also a very famous question that everyone will ask. In my opinions, right, I would say Dockers and Kubernetes are not to be compared together. Uh, the reason why is that when you come across container technology, when you first expose it, yes, Dockers and Kubernetes are the two well-known one that it just appears in every Google search that you see. But the main difference is okay, I would say is that if for someone that really wanted to get into containers technology, first start with Docker. The reason why is because Docker is lightweight. In a layman term, I would say it's like a lightweight virtual machines, but of course it's not a virtual machines. And then it runs in singles. I mean, it runs in a single node. So it's like basically you run Dockers on the local machines. That's it.
Yeah.
It doesn't have cluster capabilities and stuff like that. So when so in this case, when you use the Dockers, I would say it actually help you to focus on development. Like you focus on containerized applications, break down your monoliths to microservice, and then how you're going to package your microservice application into a container. And then learn through like how to package the dependency applications, stuff like that, and then create a container, get it run on these local machines or these single machines that you have that the Docker support on it. Eventually, once you able to do this, you kind of manage to push your containers to the public repositories like Docker Hub. So that is basically is about the path that you have for Docker. But when you come into a large scale deployments, that you wanted to have something that is like able to give you productions, environments, scalabilities, high availabilities, or like health check, and you know like things like when my containers crash, it can actually help me to auto restart it without me worry and stuff like that. And the most important part is I wanted to have a rolling updates that I update my container and then I actually have the capability to roll back. That is Kubernetes. So it is a very different technologies compared with Docker in that case. But in your learning path, you should start with Docker because eventually when you come into Kubernetes, you are still also dealing with container that you deploy a pod on Kubernetes. You still have to pull your image from the Docker Hub and then have your containers run inside the Kubernetes platform. So I would say both of them works together, but it shouldn't be compared like on the same levels. But basically you can have both at the same times. Yep.
Yeah. Awesome. I think that's a valuable piece of advice and also information to anyone who's starting off thinking about all these areas. But before we move on to the question 3, there was this interesting type of concept which came from Giri as well. So Giri was saying like before people knowing about Docker, before people know about Kubernetes, people should have a understanding about microservices. So like before we move on to this question, just as a separate question, Giri, can you give like a like an overview about what are microservices?
Yeah, so the question is, what really is microservice? Okay, that's
Yeah.
an interesting question. Actually, in the past, right? Let me give an example of Google. Right, Google has a search engine, and search engine. This is a hypothetical example. Search engine was written in, for example, Java. What Google search engine does is that users can type in the keywords, right, and then when you enter. When you press the enter button on your keyboard, it will give you the most relevant results, right? Maybe in the past, Google only have one very big Java application in order to serve this. In this very simple typing, actually behind the scene, it involves very complex logics. Like how do you crawl all the web pages in the internet? How do you sort that? How do you show it to the user? And all of those involve hypothetically in one application, right? In Google scale, obviously this doesn't scale, right? Because Google has to serve maybe before billions of users, let's say the first thousands or first 10,000s of users. this one application, and then is written by hundreds of developers or even thousands of developers. Now, if one guy wrote a buggy code so that the result doesn't show up correctly, it will crash the entire Google. Google will go down, right? Because everything is tightly coupled into one binary or one jar in case of Java, right? Now, in order to minimize that risk, the more modern way when you are in the growth phase is to break down those very giant monolithic application into small, tiny services. This is why it's called microservice. There's a web app only to serve keyword input by the users. And then there's another service, web application, only serving the results of that of your queries. There's another tiny service that does sorting your the result of the pages, and those microservices bundled together to serve Google search engine service. Before Google had one application. Now they have broken it down to maybe hundreds, even thousands of services, small services, so that when there's a bug in the result service, for example, it won't impact the rest of the functionalities, and Google will keep up. People can access it.
That's true. Awesome.
Yeah.
Thank you for that example. Taking Google and showing it how things can be broken it down, and also it makes life easier for the teams, and also it increases the development velocity as well. So now, Suat, the third question is around now, since you have worked with Kubernetes since like in your organization, and you might have experience how people can implement Kubernetes within their organizations, etc. So can you share your experience in working with Kubernetes bare metal, and how did it help to improve your development velocity, scalability, etc.?
Yeah, sure. So how do I start with this? Basically, I think if you wanted to run bare metals, it's important that you have the principles that why is it you want to do this. Because like for my organizations, the reason why we go with these decisions is more towards that we wanted to be compliant, to be secure. So having the full management controls of the Kubernetes platform itself benefit for us to fulfill this part. And of course, the most important thing is we wanted this platform to be able to integrate with the internal system that we have. So that is kind of like the original purpose we start off with. For anyone that wanted to explore this, I would say Kubernetes is very great in the way that you can actually set up in anywhere, not just bare metals. Like I remember the first ever cluster that we have. It was actually being built by engineering using the deprecated systems that kind of like they offboard from something else, and then they have a spare resources now, and then they build it up, push it as a preview so that people can start using it and explore Kubernetes for the day zeros experience. But it come quite a journey that right now we are kind of proud to say that we have a lot of clusters that are actually sitting around multiple regions that's supporting the whole globals in JP Morgan's. So that was a really great journeys from only the 2 clusters come to right now that we have so many, I think more than 40 or something like that. And the user base is like they just jump on it, trying explore it. So for the developments, I would say the way I see is that it actually benefits a lot, because think about it. You actually can code everything in a YAML file, and then you can just run your deploy by reuse the YAMLs. Meaning to say that it more or less that you don't have to change much. Like let's say today's you write your deployments, your containers, and then you can define everything, because Kubernetes provide all of this, that you can even define like how much resources your applications need, your container needs. how much CPUs you want to request, how much memory you want to request, stuff like that. And it even provide the benefit of doing configurations management, that you can just put in the configuration you wanted to go along with application container when you started. Then it's like when you define all of these YAMLs, you check into the code, you run on development. Once everything done, you can actually use back the same thing, deploys to the others environments, or to say is that you can even run to anywhere that have Kubernetes. What I mean is that it's not even just bare metals already. It's more like you can deploy some bare metals today. Maybe some days you think that I will not wanted to have bare metals anymore. I wanted to try manage services like GKE.
Yep.
You don't even have to change your YAMLs. You can also just deploy it the same ways to it, because GKE is based on Kubernetes engine as well. It was just supported. So that is great in a ways that I would say the software development lifecycle just changed so much with Kubernetes come into the picture, that you don't even have to. It's not like in the past you probably have to change so many just to cope when you change the environment. So that is what I feel the really sweet part of Kubernetes. But of course, I would say the experience managing the bare metals has a challenge as well, because think about it. Like for my organization, we basically run our own bare metal. Yes, we also have to accept the fact that we are our own vendor. If anything goes wrong, we are the only one to fix it. There's no one that we can call for help and stuff like that. And another thing is involve big investments for the you will have to think that how are you going to invest in not just the hardware resources to run this, also the talents, meaning to say that your team, the groups of staff that to support this, because you will need talents that not only knows Kubernetes. Let's say today you decided to run your own Kubernetes on VMware or OpenStack, which means you have to prepare that your talents need to know OpenStack and VMware as well. Because whatever underlying infrastructures have issue, your cluster started going to have problem as well. Your people will need to know how to fix both. So this is the challenge that we face when we go along with the decisions that to manage the bare metals Kubernetes. Yep.
Awesome. Thank you for sharing those real examples, Suat, that you have. So based on the question and the answers that Suat gave, we are moving on to the next question. Now, Suat mentioned it seems like having a managed service for Kubernetes would be fantastic. So, Giri, what do you think? What's Google Kubernetes engine, and how does it make life easier for developers?
Okay, what really is Google Kubernetes engine? I would compare this analogously to Linux world, right? In the Linux world, Linus Torvalds wrote an open source version of Linux kernel that anyone in the world can download that, compile it, and then install it in whatever machines they have. Now, in the Linux world, there are Linux distros or vendors that provide Linux distributions. For example, Ubuntu, CentOS, right, Fedora, Red Hat, and many other vendors. What they basically do is that they take the upstream Linux kernel code, and then they put a bunch of flavors on top of it, and they configure tune it so that it will be easier for users to use it. This is very similar to what Kubernetes provides. Kubernetes provides the upstream code base that we can basically download and set up ourselves. What we need to do is we need a bunch of machines. Even one machine works, but it won't work in production. You need a bunch of machines. You set up a control plane with that code base, and then you join a bunch of Kubernetes nodes so that it works as a whole cluster. Now, the question is, do you stop here? The answer is not, because this only provides vanilla Kubernetes cluster. You will still need a bunch of other add-ons, I would say, or flavors, so that your workload can run better in a better way in the production. For example, you need monitoring system, right, which vanilla Kubernetes cluster doesn't provide. You need a logging system, which again vanilla Kubernetes cluster doesn't provide. You need machines that can auto scale, which again the vanilla Kubernetes cluster doesn't provide. So then there's another day to operation challenge where you need to perform security patches. There's this new version from the community that new version keeps coming every 3 months, right? How do you make sure those new Kubernetes versions keep being applied in your cluster so that your cluster stays up to date and doesn't vulnerable with security flaws? That's a lot of work, right? And that's a lot of work. You need to make sure your cluster doesn't break and your company doesn't go out of business because the cluster goes down. This is where value of managed Kubernetes cluster comes into picture. What Google Kubernetes Engine provides is a managed Kubernetes cluster, so you don't have to worry about setting up all of the add-ons that will make life easier in production system. You don't have to care about maintaining the upgrades because Google does the auto upgrade for you. There's a bunch of channels where you can subscribe, and then Google tests extensively in their Google infrastructure before releasing to the customers. And Google provides all those add-ons. So if you're running out of machines, Google can auto scale, adding new nodes into your cluster so your cluster keeps healthy and things like that. So think of Google Kubernetes Engine as a Kubernetes distro, which makes life easier for you. So yeah, if you take, for example, a tool to bootstrap Kubernetes cluster, maybe it will take half an hour, or if you're new, it can take hours to set up. In Google, you can just go to console.cloud.google.com and then go to a GKE bar. There's a blue button there. Single click. In 1 or 2 minutes, you get the cluster ready for you.
Yeah, awesome. So thanks, Giri, for that explanation. So the final question in rapid fireside chat. Now, Kubernetes is becoming kind of a global norm. A lot of people try to use this. A lot of people try to, a lot of organizations speaks about it. But there's this fundamental question a lot of people would ask, hey, is it the right time that we should start using Kubernetes into in our systems? So according to, like, this question goes to both Giri and Suat, because you have experience in using Kubernetes. So at which point do you think companies should start using Kubernetes? Should it be like, if it's a startup, should they start from day one? Or do you think they can is it only for the companies who have very structured or legacy system, they should start moving into Kubernetes? Which point do you think they should make a decision on using Kubernetes? Question to both Giri and Suat.
Yeah, you want to start, Suat?
I can start first if it's all right.
Okay.
In my opinion, I think this is really very based on situations. So like what you mentioned, if it's a day one, and you know that your business nature is you wanted to be cloud native, you wanted to do containers and stuff like that, go ahead. Because I would say you already have your roadmaps of thinking that this is what you want, and you will come along Dockers, containers, and stuff like that. And once you have these foundations, move to Kubernetes, because it provides all the benefits that you have as an early adopters. Like all the things that we just talked about, scaling, the flexibilities of having all the distro you can choose, because GKE is one of the distro. AWS has the Kubernetes versions as well. Your options is open up so much. And let's say if today you say, you can also choose to be bare metals as well. I mean, like if you really just start small and you have those spare resources that you just wanted to try, you can, because set up your own cluster has made so much easy with the tools that's provided, the kube admin tools. But of course, back to what Giri just presents, that you might not have the other things that you wanted, like those scalers and stuff like that. But it's always served as a very good start. I will even say, let's say today you are so small that you only have 2 or 3 developers. run a Minikube on your local machines. That is as well the most basic Kubernetes you're going to have, and then you can just do it like the development environment started exploring Kubernetes. But the answers goes to depends is also based on, let's say today you have a lot of legacy system. Most of your applications is a monolith systems that's running on a virtual machines. I would say you might want to push back the decisions about Kubernetes because you are going to have so much to learn. Like you're going to think, is it possible that you can break down the monoliths to run on a container? That's going to be a first step. And then you also have to check your current teams have the time to pick up or not. Because not only is that you're going to have to support your current development, you also have to spare time to learn all of this. And then going through a very big changes on your development cycles to make such changes. And not to say that you also have to learn Kubernetes. And Kubernetes is kind of well known for having a steep learning path. I would say in this case, you might end up you have too many on the plate. You don't know what to focus. You don't know what to prioritize. You might just end up more the technical steps that you have to solve in futures, and you might not be able to even give a very good qualities of products. Yeah, that is my opinions for this part.
Awesome. Giri, what do you think?
Yeah, similarly, if I start my own startup, I wouldn't use Kubernetes from the beginning. Why? Because startup doesn't have that many engineers, right? At first, what startup usually focus on in the beginning is to build the right products, deliver business, and they usually don't care about infrastructure that much. Otherwise, there will be a lot of overhead over there. But then the startup is successful. It gains traction. It's growing so much. There's the hockey stick. At some point, you will need to break down the monolithic app that you have, startups have, into microservices in order to bring back the agility of the development and business delivery. At this case, this is where cloud native infrastructure, the best fit for you. At this point, you will need to manage more and more services. This is where Docker containers will be good for you, so that your developer's life will be easier. And then after Docker, this is where Kubernetes comes into picture, because there has to be something that manages your Docker containers easily. Once you adopt Kubernetes, it opens up a bunch of great possibilities in the cloud native ecosystem. I can actually share screen. There's a good path that provided by the CNCF. Are you able to see my screen?
Yeah. I'm sharing the screen.
So CNCF, or Cloud Native Computing Foundation, is the actually subgroup of Linux Foundation, which oversees Kubernetes project as well as the cloud native ecosystem. They have provided us with the guidance on how to adopt cloud native infrastructure in general. You can open up this GitHub project, CNCF/trail map. There's this trail map or a way to adopt Kubernetes and cloud native ecosystem in your workplace. The first step is what Suat mentioned. You will need to adopt containers first before going to Kubernetes, right? The first step is containers. Obviously, there's a prerequisite here that you need to have more than one service. Otherwise, it's overkill. If you have one service, you package it as container and then deploy it in Kubernetes, one service running in a bunch of machines, that's overkill. In my opinion, you need to have microservices first, at least 3 or 4 services. That's a great start. Then package it with containers. Now, it's not just Docker containers. Nowadays, Kubernetes doesn't only support Docker, and there's many container runtime in the community out there. Like, for example, there's a CRI, there's also other container runtime. And Kubernetes itself supports Docker as well as other container runtimes. Once you adopt containers, the second step is CI/CD, because the theme of this cloud native ecosystem is that developers can gain velocity and deploy their code easily and faster into production. There's no point of adopting Kubernetes without having CI/CD. CI/CD stands for continuous integration and continuous delivery. so that ideally every commits that developers make will go to production safely. And this is where CI/CD comes into picture. And then the third step only, this is where Kubernetes comes into picture, where Kubernetes will orchestrate your containerized workloads. And there's a bunch of questions asking about Helm. This is also where Helm comes into picture. Then after this only, there's a bunch of great possibilities that opens up because of adopting Kubernetes, like observability analysis. And there's a recent movement of service mesh. Where's the service mesh? Oh yeah, it's here actually. Service mesh, where you can perform A/B testing, canary stuffs, and all those service discovery, and a bunch of other stuffs. I hope this is useful. If you're curious, cloud native is a relatively new landscape. There's a landscape.cncf.io where you can see a bunch of tons of offerings by various cloud providers, as well as open source communities that comes under this latest cloud journey, actually. I would say cloud movement or cloud evolution. I hope this is useful.
All right. Thank you, Giri. I think our friends have shared the link as well if you're interested to learn more about the trail map and try to see where your journey fits in and take necessary actions accordingly without blindly getting started off with Kubernetes because it's the coolest kid in the block. You might want to consider where your where your organizations in and accordingly fit in your technologies and tools. Awesome. So we had a very awesome session around rapid fire search. So that ends our rapid fire search session now, and we are now moving into our cloud deep dive session, where we'll be talking about on a certain topic, where we'll get opinion from both Giri and Suat on these particular areas. So the question is, what are common challenges you have faced in during Kubernetes orchestration and managing deployments, and some of the solutions, if you may mention, when you face those challenges that you use to overcome those challenges. So discussion flow is open to both of you. So you can continue on bringing on different perspectives into your challenges and solutions. All right. So who wants to go first? Who wants to start?
Please, what?
Okay. So okay. My job duty is to support developers for the smooth transitions using Kubernetes. So I would say the common challenge that I see is when it comes to deployments, when the developer is using Kubernetes to do deployments, I realized that I mean, if when you follow the step to run the things like kubectls, apply and stuff like that, things seems to be great. But when the thing is not running, it's like when your pod started failing or even get into some odd behavior, that was why everyone is going to be panicked. Like, oh, I don't know what's going on with this. And then they will started reach out to me and ask, why is it my pod is crashing? Why is it this and that? So I realized that the challenge is not really on the technology or infra, it's more on the knowledge and the learnings. Like how can you know it's really like a how to say a whole new learnings and concepts again, because Kubernetes doesn't use containers. I mean, you know you're still running container, but Kubernetes doesn't call it container, it call it pod. So it's like there are so many new concepts that suddenly you have to learn what is pod, what is service, what is endpoint, what is deployments and stuff like that. Giri has just mentioned earlier on, like developers just like to focus on, I just want to code. Don't give me all the things to worry about, the infra, whatever. But unfortunately, when you expose to Kubernetes, you have to expose to all of these new concepts, because you are the ones that is going to utilize all of these. Like you actually can, like you probably have to learn how to do resource management, how much your containers and your pods is going to need, how much you should request for all these resources, and when do you need it and when do you not, and things like that. And of course, the debugging a pod and container has become quite difficult, because sometimes Kubernetes doesn't give you a very straightforward error message. Like, it will give you some things that just tell you something crashed, and then when you look into events or logs, you just don't see what is going on. It is so different from how you used to work. So I have to say that every time I have to share a lot of documentations to the developers, and then or even like get into the call, explain some concepts to them, why is it things is like that and stuff like that. Like for examples, I remember it's just one of the use case that I faced, that how my user reached out to me and says, hey, my pod is crashing. But when I test this on local machine, everything seems fine. My container is working fine. Why is it my pod is crashing? So when I look into his case, I realized that he configures those liveness and readiness, especially the liveness pod. So liveness prop is what doing the health check for you, to make sure that how you're going to check is also you are the one that's going to define. Like, do you going to check it on a certain HTTP port, or do you going to run a command just to make sure something is running? That's where liveness define. This determines that your container is healthy, great, and things is okay. But otherwise, what liveness will do is it will think that your container is not healthy, your pod is not healthy. I'm going to help you to restart it. And then you're going to see the funniest behaviors, how your pod just keep crashing, restart, crashing, restart, and you just don't know why. But then when you test it, everything seems fine. So for these users that I have, what was the mistake is that he have the wrong health check. He basically just copy paste the code from some documentation, put it, and thought that that's where I'm going to do my liveness and health check, and that's where it started failing. So I would say this is the challenge that you're going to face when you started learning Kubernetes or deployed to it. Good thing is Kubernetes has a very large community that you can reach out to, and there is also documentations that you can find from Kubernetes.io, the official documentations. They have everything. They have tasks. They explain about concept. They even have some use case studies to show. Otherwise, you can also just kind of ask your questions in Stack Overflow. I've seen how Stack Overflow has been growing, that so many people is asking about community questions, and a lot of people is going to jump in and help you. So just join the open source community. I think this is what open source means this day, that everyone just started sharing the knowledge in the same community. Yep.
Awesome.
I second what Suat explained, right? The open source community in Kubernetes is super welcoming to everyone. We're trying to be very inclusive to everyone who is even new, any country, any race, any ethnicity. We are very open. There's even a diversity scholarship for underrepresented countries, so that they can join Kubernetes conferences. There's KubeCon, CloudNativeCon, Kubernetes conferences organized 3 times every year, one per continent. So the upcoming one is the one in North America, because the event is virtual. We can join from anywhere in the world and learn from the other companies as well who have adopted Kubernetes. And back to the question. Okay, the question is the challenge. In addition to what Suat explained, the major challenge, in my opinion, is to maintain the Kubernetes version up to date. How to upgrade the Kubernetes clusters, because the upstream community itself is still rapidly, developing stuffs. They are rapidly releasing new versions every 3 months. The security patches can come in at any time, can even in weeks or daily. And why is this important is because of this speed. The community only support 2 or 3 versions behind the latest one. This means if you don't maintain your cluster well, your cluster will be out of date. Now, when we want to upgrade the cluster to new version, it's not as easy as it is in the docs, because you need to make sure that your workload is still running right after you upgraded the cluster. Also, during the upgrade process, your workloads should still be able to serve the traffic, or the traffic coming from the users and things like that. It's not that easy. And what makes it really hard is to keep up the pace with the 3 months release cycle that upstream have. And this also has been a challenge in cloud providers, right? For example, GKE latest Kubernetes version is 117, whereas in upstream it is 119. But among other cloud providers, Kubernetes GKE is the one that keeps up to date very quickly. And I guess that's my addition to what Suat explained.
Awesome. So I think there are a couple of questions around like the updates and also the security, regarding security as well. I think during Q&A we can answer. Now, to add on to that, Giri and Sual. So now, when you're using Kubernetes, sometimes like in terms of like when you're managing your deployments and also when you want to kind of orchestrate, a common like an area which a lot of people would also talk is that how you can automate that piece as well. And automatically people will start thinking about how can I use Terraform, how can I use like infrastructure as a code. So have you had any challenges around using infrastructure as a code, or like any of the usage of tools when you want to use it along with the Kubernetes?
Can I go first?
Yeah.
Okay.
Please.
Yeah, so in this modern cloud native infrastructure, there's this movement to code your infrastructure as well.
Yeah.
In the past, when people still manage their own data center or machines, they would go to the location and then plug in their laptop and then configure the servers there. Right? It's no longer the case right now, because it's really hard to debug what's going on, what is the latest state in the machine, and things like that. Things can go wrong anytime. That's why there's this new modern term called infra as code, or infrastructure as code, pioneered by HashiCorp friends. They made a tool called Terraform, so that you can configure your infrastructure with what they call HCL, or a custom language, so that you can declaratively configure your infrastructure. This also includes how you configure Kubernetes cluster. There's a Terraform Kubernetes provider that will help in writing the code for your infrastructure. Now, what makes Terraform great is that it stores the code into a version control, like Git, for example, so that you can audit the changes and then treat the infra code that you commit to the Git as a source of truth. So once there's a difference or drift, we call it drift, between what we stored in the Git as well as what is served in the infrastructure, the tool can detect that and then perform corrective action. Right? When you run Terraform apply, you can see, oh, someone has been manually changing stuffs in the data center, in the machine. We need to correct this out. Otherwise, things can go wrong sometime next month, maybe. Now, this is what is the standard right now in the industry. Now, there's a next movement, not just infrastructure as code. The next level is infrastructure as software. In the infrastructure as code, humans still, write the infrastructure and manages the code. In the infrastructure as software, software manages the infrastructure for you. This is the case where you can use Kubernetes to manage your virtual machines or your infrastructure or your networking components. Because the value of Kubernetes controller, you can extend it to solve whatever problems you are facing. And the difference here is that the corrective action will be performed automatically by the software, the Kubernetes controller itself. This is where Kubernetes power comes into picture, right? You can reuse what they provide. The database, for example, you no longer need to have your own database, but you can use Kubernetes etcd to store the data for your controller so that your controller can be resilient, things like that. This is another movement. If you're interested, you can read the book called Cloud Native Infrastructure, written by one of the Kubernetes community leaders, Chris Nova. You want to add something, Suat?
I think you basically covers everything. Because from what I know is that yes, Terraform is one of the good tools to manage your Kubernetes, and as well as you can also introduce Ansibles to do your configuration management, like any kinds of configurations you want to keep track on. And then you basically can just check in and has Git to do all the version controlling on your configurations. And I believe you can as well set up a Jenkins just to have a pipeline so that it actually helps you to kind of run these playbooks and then deploy the cluster for you, or even rebuild the cluster for you for any kinds of maintenance activity they have, instead of you have to do it in the manual ways. So this is one of the, I would say, is like trending right now, is that moving along with this. I mean, like all these tools are to make our life easy. We don't have to do so much manual stuff and developments anymore. Yep.
There's a new term for that as well, called GitOps or Git operations. If you want to learn more about it.
Yeah, pretty cool. So I think we had a very good conversation around how people can manage and also orchestrate Kubernetes, and how you can use infrastructure as code as well. So I think we have a bunch of questions which have come in, so we can move into our final section, which is the Q&A section. So that wraps up our deep dive into cloud piece. So now we can move into the Q&A. So the first question, I think is from someone called SL Gentleman. A few weeks ago, there was a security patch release for GKE clusters. Upgrading from GCP console, will it handle the active connections draining without interrupting the active connections?
Yeah, I can help answer that.
Yeah.
This is basically the challenge that I mentioned earlier. It's about the cluster upgrade. So in Kubernetes, there are two upgrades, right? One is security patch. Usually, it bumps up the patch version of the cluster, and then the second one is the minor version upgrade. What this question is asking is about security patch. In general, security patch releases is pretty safe and much easier to apply in your cluster because it doesn't introduce breaking APIs. Whereas the minor version upgrade, it will introduce breaking APIs. For example, when you have cluster 115, you want to upgrade to 116, all the deprecated APIs will be removed. So in your manifest, if you're still using the beta APIs of deployment, daemon set, I think stateful set, and other resources, it will start breaking if you upgrade it directly without fixing your manifest first, your workload manifest first. Now the question is back to the question: will it handle active connections draining without interrupting the active connections? This is where you need to apply some best practices when you configure your deployment. For instance, you need to configure liveness probe as well as readiness probe. So when your application is not really ready, Kubelet or Kubernetes doesn't really route the traffic to your pods or your containers. So this is also the case for upgrading. When during the upgrade process, the upgrade will be in rolling fashion. So, for example, you have 3 worker nodes. Your pods spread across 3 nodes. When you perform cluster upgrade, the upgrade will be performed one by one. From the node 1 first, it will disconnect the traffic. The node will get offline, introduce the new node with new version, and then rejoin the cluster and things like that. It will be in rolling fashion. So you can design your workload in such way that the pods spread evenly across the nodes. It will be more helpful. And another best practice is to handle graceful shutdown in your application, so that when there's a term signal killing your container, your app doesn't exit directly. Because, for example, if your application still processing requests from the users, and then Kubernetes kills your pod, the users that get process will be gone, right? What if you are a banking company? The money will be gone. So we don't want that. So best practice is to handle graceful shutdown in your application in the code itself as well. So liveness probe, readiness probe, and startup probe. Second, handle graceful shutdown in your code. Third, maybe enforcing affinity so that your pods are spread across the nodes. If you have 3 pods, you make sure that all those 3 pods are not running in the same node. So if this node gets killed during the upgrade process or any hardware failures, the pods will still be able to serve. Lastly, enforce something called pod disruption budget. So there's a minimum number of replicas that your pods maintain during the upgrade process. For example, you set pod disruption budget to be 3 pods minimum. The Kubernetes will ensure when it kills the nodes that contain all of your pods, for example, Kubernetes will move your pods to other nodes first before killing the node. It respects the minimum number of replicas and something like that. If you're curious, there's a good link about Kubernetes best practices in production. I can share.
Yeah.
Should I share my screen?
Yeah, you can.
Share screen.
All right.
Okay.
Let me enter the screen.
Yeah, there's this. Are you able to see my screen?
Yeah. Yeah. But
Yeah, there's this Kubernetes training company that does really good job in educating people in the community. learnkas.io/production best practices. You can find a bunch of best practice checklists here, including application governance and your cluster configuration. For example, your application needs to have a health checks. Containers need to have readiness probe. What is readiness probe? It is explained here. Then your containers need to crash when there's a fatal error. This is also best practices. You should let it crash so Kubernetes knows the signal and things like that. There's a bunch of. This is what I told you. Graceful shutdown. The app doesn't shut down on sick term, but graceful terminates connections and a bunch of other things as well. You can audit your workload and follow this checklist one by one. It's a good checklist and good learnings as well.
Okay. Awesome. All right. So, Suat, do you want to add anything?
Oh, I think Giri kind of.
Giri covered it all. Yeah.
I mean, the graceful shutdown is a very important one because I realized a lot of people actually doesn't know the behavior of it. Yep. So basically, if you do this right, it's just like what Giri says. At least you don't get your stuff just get killed and then you'll be like, hey, what's going on? My application is dying because you might not even have. I mean, you might not. You have to suffer the data loss, perhaps, like because you didn't handle this. Your data just lost when the nodes kill your pod. So this is a very important one that I realized that a lot of people might not aware of it. I mean, liveness and readiness is already like kind of like talkers amongst the communities, but graceful shutdown is very important. Yes, I would like to emphasize that. Yep.
Awesome. Because we have a couple of minutes left, so we can take about another 2 questions, which are in the live Q&A. Let me pull out this question from. Let me pull this question from Harizuan. How to deal with database migration that may take a long time to run? When nodes may go down anytime, what can be done to manage the risk of this task?
You want to take this one?
This is kind of a tough question. Many times
this is about running stateful workloads as well in the Kubernetes, right? Yeah.
It sounds like it. I mean, in most of the cases when if a user raises questions about database, usually I'll ask them, do you want to consider if your workload is suitable to run in Kubernetes? If if you are not ready to have your if you are not ready to have the mindset that things could happen in what Giri had just explained in all the things, because the nodes could go into maintenance, your cluster could have to upgrades and then evac your pod. I mean, even to the point that let's say in this particular nodes that your pod is running this migration, and unfortunately you did not do the best practice of having the guarantee or stuff like that. You probably just use some best effort QoS, and then this node started having the pressures that it doesn't have enough resources. It might evict your pod. In that case, your workloads might also being interrupted. So when it comes to this kind of scenarios, I will seriously think about the considerations that, hey, do you think that your workloads really suitable to run in these environments or not? And if you do wanted to try, you will have to do the like maybe some bad practice on the code, just like what Giri had just shares about handles the graceful terminations when you get the system, start save all your data and things like that, so it doesn't suffer the data loss. Then your pod can safely move to somewhere else and continue whatever it's supposed to do. Yep.
Awesome. Giri, anything that you want to add?
No, Suat has covered it quite well.
Awesome. So I think we have a lot of questions coming in as well, but due to time restriction, we will have to take the questions later. What we'll try to do is we'll try to get our speakers to help us out to compile a little bit of answer for most of the questions that you have posted up over here after the event. So any final thoughts or final comments that you want to share? Because today we had a lot of very good insights into Kubernetes and the resources and docs from both of you. So any final thoughts that you may have in terms of people who are using Kubernetes and GKE that you want to share across?
Okay, I can go first. Kubernetes is 5 years old project, so it is still rapidly evolving, and you're not alone if you face difficulties. There's a bunch of other folks ready to help you out in the community. So don't hesitate to join the Kubernetes community. Join the Slack channel, kubernetes.slack.com. And then if you find anything weird in the Kubernetes documentation, please raise issues in the GitHub, or if it's better as well if you can fix it and then raise a PR so that you can contribute back as well. Do share your stories, because we need more and more end users case studies and stories. Adopting Kubernetes successfully in their workplace. Yeah, that's all.
Awesome.
Good luck in your journey learning Kubernetes.
Awesome. Suat, what are your thoughts?
I would say prepare to fail a lot, learn a lot, and read a lot. One good thing that I would say, try to look up. Search those use case studies. I mean, a couple of days ago, I actually come across articles that GitLab actually shares in their blog about their journeys and experience of running, migrated their workload from virtual machines. They used to have just run things on virtual machine. They migrated to GKE. They share a long blog post about the challenge that they face, the issue that they see, and how they come across making some decisions to improve the performance and things like that. All of these are a really good reading. It actually kind of like, before you encounter the error itself, you read from someone else use case that you understand what this thing is going to be, what you're going to face as well, because everyone is going to walk through the same path and may encounter the same problems. So read a lot and just play around with it. Have fun with Kubernetes.
Awesome. Thank you very much, Giri, and thank you, Suat, for joining us today. Today was one of the, as I mentioned in the start of the event also, like a lot of people were asking about, hey, can we talk about Kubernetes and GKE? And I think we try to do a justice for your request today. Some of the questions we weren't able to answer, but we'll try to answer at least through a different event, or maybe through a different blog post. So those questions also can be answered. And please do check out the links which are being pasted in the live chat section, because I think those some of those resources you might have seen, you might not have seen. So please make use of those. So I think with that, we can say thank you to both our speakers, and we can say adios for today, so that we can get you to the next section, which is the feedback section. And also we want to share a couple of the free training which are available. So thank you, Giri. Thank you, Suat, for joining with us today. And we are hoping to see you soon again.
Thanks for
Thank you
the
so much,
questions today.
Shafras.
Yeah.
Thank you. All right. Thank you, Suat. Thank you, Giri, for joining us today. And then there are a couple of information that we want to share with you. The first one is, now, since if you're new to Kubernetes, you might want to try out, get hands-on experience around Google Kubernetes Engine as well. So let me share. There's a free training available for you, which you can get from the link. Let me share the link with you. All right, so if you go to this link, you'll be able to get free access to Quick Labs, and also training materials from Coursera and Pluralsight as well. And there are two events which are currently happening in Singapore and Indonesia. Modular GCP is happening in Singapore. If you want to learn more on machine learning and data analytics, and get some swags as well, please do sign up through this link. The final date to join will be on the 11th of October. And if you're from Indonesia, you can join through this link. We have the same program for Indonesia, and you can score swags, and also you can learn machine learning, data analytics, and also infrastructure related topic areas as well. So sign up to this free training material so that you can be successful through the journey. And with that, I would want to say thank you for tuning in throughout the program today. And there's a small feedback form that we want you to fill us up, so that we'll know what are the future topics should be, because these feedbacks brought us to talk about Kubernetes and GKE today. Similar to that, if you have any other topics that you want us to discuss through in the cloud sessions in the future, please do drop us a drop us a feedback, so we'll be able to help you out. So let me share the link to it. All right, so this is the link to the feedback from. Please take a couple of minutes to fill this up, and we can we can use that as a material for our future events. All right, so I think you were able to take a note of the feedback form. If not, we'll be sending you a separate email as well with the feedback link. Please do go and check that out, so we'll be able to get your feedback and improve on the future programs. And don't forget to subscribe to our Developer Space channel, and hit the bell icon, so you'll be notified with the latest events, and also the latest events, latest videos from Google Developer Space Singapore. So until we meet up again with another edition of In the Cloud session, stay safe, stay healthy. See you again on next event. Thank you.